So your office hours are they from
2
2 to 2:30
to
or are they
2:30, Monday to Thursday, and then Friday morning, hold on one second.
it's like 9 to something?
Friday, 9 to 9:50, okay?
Okay.
All righty? All right, so, hello? All righty. So, the last thing that we did, the thing we didn't get to the other day when we were doing our little review, was this thing about the angle of elevation and depression, okay? So we'll just go over that a little briefly, right? So, when we talk about the angle of elevation, right, we're talking about the angle formed from the ground up. So that angle right there. Everybody understands that, right? Did everybody see that? Did everybody see that? All righty, good. Now, that's not that big a deal. And we can use what? We can use our trig functions. We can use a lot of stuff when we know that. Now, here's the mistake people make though. When they talk about the angle of depression, they always think it's this one right here. But that's not true. The angle of depression is always from the horizon. So you have to actually draw the horizon line, and this is your angle of depression. Now, this horizon is going to be parallel to the ground, shall we say, right? So these become what? Alternate interior angles. Does that make sense?
Yes, sir.
So here's what we know. The angle of elevation and the angle of depression are going to be congruent. So people make mistakes though, because they think this is the angle of elevation. But that's not a big deal, because if we know that's 90 and we know that measure, then we know that measure. Does that make sense?
Yes, sir.
Now, most of what you're going to do with that is going to be in word problems, right? So do you have your workbook with you?
Somewhere.
Do you have it available?
Yes.
Right? So if you look at, let's say, if you look at page 106, right? You look at page 106, number 3, right? And the biggest thing here is when you actually do these problems, all right, Mike is trying to get in there. All right. When you do these problems, the hardest thing is, what's up, Micah?
How you doing, Coach?
Not bad at all. All right, so we're doing angle of elevation and angle of depression right now. So the thing that's most important when you do these problems is translating the words into the picture. So if you have page 106, number 3, right, I'm just gonna, when you do word problems, fellas, what you wanna do is read it straight through the first time without stopping, right? A student can see a water tower from the closest point of the soccer field at San Lobos High School. The edge of the soccer field is about 110 feet from the water tower, and the water tower stands at a height of 32.5 feet. What is the angle of elevation if the eye level of the student viewing the tower from the edge of the soccer field is 6 feet above the ground? All righty, so here's what we know. So like if I was gonna draw a picture of this, Ceebus, you're gonna be my dude, right? Here's my man, Ceebus. Is that you, Ceebus? Looks like you, right? And he's standing at the edge of the soccer field. And way out here in the distance is this water tower that he's looking up at. Everybody got that? Yes?
Sure.
So what do we know? The water tower forms a 90-degree angle with the floor, right? With the ground. And what? He's 110 what? How far?
110 feet.
Right? Now, they tell you that the water tower is 32.5 feet. Now, what else do they actually tell you?
That you want to find the angle of elevation based upon the student's line of
Eye
sight.
level. How far above the ground is Ceebus's eyes?
6 feet.
How much?
6 feet.
Ceebus, you think you're 6 feet tall?
Wow.
All righty. So here we know that Ceebus is 6 foot tall. So we're talking from here to here. So this here isn't the angle. And of course, his eye is, so this is the angle of elevation. Does that make sense? All right, now, the water tower is 32.5 feet high. But since Cebus is 6 feet, what actually is the side of this triangle?
26.5.
Beautiful, 26.5. Does that make sense? So be careful with that on your test. If the angle of elevation was from the ground, it would be 32.5. But when they give you like the so-and-so is 6 feet tall, now you got to say to yourself, what do they want you to find, right? What is the angle of elevation? So there is your unknown. What is this angle right here? So in your diagram, you could actually get rid of this part of the picture. You don't need it anymore, and now you have this. All righty, now it's just an algebra problem, and you know that you're trying to find an angle measure, so what are you going to be using?
Inverse.
Thank you.
Tangent.
Always, always, always. As soon as you see an angle measure. All right, so what are we going to set up here? This is the angle I'm looking for. What two pieces of information do I know?
Opposite and adjacent.
Very good. What is that?
Tangent.
Tangent, yeah.
So the tangent of x has to be equal to 26.5 over 110. Does that make sense?
Yes.
Yep.
Sure.
So I don't want to know what the tangent of x is. I want to know what x is. So now I'm going to use the inverse. So the inverse tangent of 26.5 over 110 will give me what x is. And if you plug that into your calculator, what should you get?
About 14 degrees.
Well, it depends. It says round to the nearest tenth.
Oh, so 13.5.
Yes, make sure on your exam you pay particular attention to what you have to round to. Does everybody got that?
Yes.
Everybody knows how to manipulate that, right? That's not a big deal, right?
Yes, sir.
Not a big deal, right?
No.
All righty. Let's see. Anybody have any question on angle of depression?
No, sir.
All righty. So here's what I know. We've gone through everything that's on your exam. So now you're free to ask me whatever you feel like you might have trouble with. Or if you want, you can just start doing your test. Right? Anybody have any? Yes, Sebas.
I had trouble on our last homework. Those last couple of problems, like 4, 5, and 6, I had a little trouble on doing.
Is that the law of sines?
Yes.
Okay, good. So the law of sines, all right, what does the law of sines talk about? It talks about the relationship between angles and sides of a triangle. But we're talking about triangles that are not right. All right? We're not talking about right triangles. All right? Let me just erase. So, laws of sines. All right? Anytime you have a triangle, draw any triangle, not a right triangle, any triangle. All right, how do we label triangles? Angles are capital letters, and the sides are lowercase opposite the angles. So it's important that you understand that you have to label your triangle that way. All right? And then once you do that, okay, there are certain ratios that are always equal. So the sine of angle A over side A is going to give you the same number as the sine of angle B over side B opposite. And that's going to give you the same number as the sine of angle C over the side opposite. Does that make sense, Hector?
Yes.
Okay, so that's all you got to remember, that those are the ratios that you have to set up. The sine of an angle over the side opposite equals an other angle sine over its side opposite equals the other angle sine over its side opposite. So what does that allow you to do?
It allows you to.
Anytime you have a triangle and you know at least one angle and the side opposite,
Mhm.
you know this is true, so you can use that to your advantage. Does that make sense?
Yes.
All righty. So the last homework assignment you had on the law of sines, okay? The last homework assignment you had on the law of sines. So like if we look at, that was what, page 107, right?
Yes.
All right. So if we look at page 107, let's take one where we have to find a side first, right? Is that where you're having trouble, or is it when you have to find an angle?
It's when I'm finding an angle.
All right, so let's do the one where we find a side first. All right, let's see, let's pick one. Let's look at number 11. Do you see number 11?
Yes.
All right, so now notice they don't use ABC. What do they use?
RPQ.
QR. Doesn't matter, right? It's 3 letters, right? So this is number 11. It looks something like this. Notice it looks like a right triangle, but it isn't, right? How do you know it isn't?
Because it says it's 89
Because it
degrees.
tells you this is 89, right? So they tell you that angle's 89. They tell you this side is what?
16.
16. They tell you this side is
12.
12, right? They
Yes.
tell you this side is,
X.
oh, my bad. Wrong problem. That's not the law of sines, my bad. Let's do one of the early ones. We're getting into the law of cosines. We didn't do that, right?
No, we have to cosines.
All right, let's look at number 7. That's a better one. C, A, B, right?
Yes.
104. This is X, right?
Yes.
This is 22, and this is 18. All right, now, Hector, you have a triangle that's not a right triangle, so we can't use Pythagorean theorem. We can't use trig ratios, because that's for right triangles, right? But we do have a what?
We have
a
an angle on the side.
We have an angle and the side opposite. Now remember, sometimes they give you this over here, and they give you these 2 angles. If you know 2 angles, you still know the third, right? Always remember, once you know 2, you know 3. All right, so what am I going to set up here? Hector,
So sine of 22 over 18
equals?
equals the sine of b over b, or over little b.
No, we don't care about B over there. We're just trying to find that.
All right, so the sine of 104 over c, or x.
X in this case, yeah. Beautiful. Now, what do you got there? You got an equation between 2 fractions. So what do you got to do?
Cross multiply.
There you go. You got X times the sine of 22 has to be equal to 18 times the sine of 104. And of course, that's easy to get X. What do?
You divide by the sine of 22.
And whatever you do to one side,
You do the other.
all righty, good. And then if you plunk that into your calculator, what do you end up with?
I'm doing it right now.
All righty.
46.6.
46.6. Okay, good. Now, I wonder if that makes sense. Do you think it makes sense? This is 22, that's 18, that's 104, and that's 46. That sort of makes sense to me, right?
Mm-hmm.
Yep. And then if I asked you to find that, you would just figure out what that angle is. All right, so, but that's not what you had trouble with, right? You were talking about when you have to do what? Find an angle measure.
Yes.
So here's what you remember. Anytime you're using this, when you're looking for an angle measure, once you get into the trig part, you're going to be using inverses, right? So let's look at page 107 again. How about we look at number, let's see. Let's look at number 6. That's one you had to do for your homework, right?
Yes.
All right, so we draw the same picture, right? All you gotta do is make sure you label, right? So we got A, B, C, right? And here's what they tell you. They tell you angle A is what you're looking for. All right? And they tell you C is 83 degrees. They tell you side C is 20. And they tell you side A is 12.
Can you
Alright.
move up the camera?
Yep. And if you're looking at your workbook, this is number 6. Okay? All righty. So now, Hector.
Yes.
All right. So what am I going to do here?
So what you're gonna do is the sine of 83 over 20.
How come I can use the law of sines? Because I have
Because you know
and the
what
side
angle
opposite.
side.
Once
Yeah.
you have an angle and a side opposite, you're free to use the law of sines, right? Does that make sense?
Yes.
All righty. So I'm going to do what? The sine of 83 over
20.
20 has to be equal to
The sine of x over
the
12.
sine of x over 12. That's all you got to remember, fellas. You're looking for an angle and the side opposite. All righty? And then, of course, what do we do, Hector?
Cross multiply.
So we got 20 times the sine of x equals
12 times the
12
sine of 83.
times the sine of 83. Now we just have to do the algebra. Get x isolated.
So you divide by 20.
There you go.
On both sides.
So you end up with the sine of x equals 12 times the sine of 83 over 20. But I don't want to know what the sine of x is. I want to know what x is. So what do I use?
Inverse sine.
And what you do is you just switch the x and the number, and then you end up with the inverse. Use the inverse. So the inverse sine, not of x, but of 12 times the sine of 83 over 20 equals x. And now if you take out your calculator and you plug that in, what do you get for a degree measure?
My calculator won't let me do it. It says that there's like some sort of domain error.
Hmm.
Hold on a second. Because I have it in degree mode.
All right, so you have it in degrees. Did you
Okay.
actually close the parentheses after 83?
Yes.
7.
All right, so you got,
Hold on a
Well-
second. Let me show you my well, let me see if I can get rid of my background here so I can show you what I did.
36.5, right?
it's you should get 37.
Yeah, 37, but
Yep.
no.
Can you see this?
Yeah, I can't see that, Hector.
Okay. But like I entered it, so I did inverse sine of 12 times the
No,
sine
no,
of
no, 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 no. Yeah, you got to do like the inverse of, not 12. You got to do the inverse of 12 times the sine of 83.
Okay,
For
so
20.
12 times.
Well, no, I'm sorry. What am I talking about? Do 12 times the sine of 83 divided by 20.
Okay.
You get 0.596, right?
Yes.
So do the inverse sine of 0.596.
Oh, okay.
All righty, you got that?
Yes.
All right. Does that make sense now?
Yes.
What you get?
Hold on, let me do it right now. About 36.5.
Yeah, and you'd round that up to 37. Does that make sense now, Hector?
Yes, it
All
does.
right. So it's just an input error, right?
Yes.
Brenda? Yes, Buchanan.
So I don't know if you can answer this, but so 9 through says 9 through 11, sketch a problem, show and label a right triangle, and solve the problem by showing all your work.
What
Would
page are
that
you on?
be? Well, I think maybe.
It's on the test.
Yeah.
Oh, on the test. Okay, go ahead.
Well, I'm not asking about a specific answer.
Yeah, no, just ask your question.
So for 9 through 11, is it
Yep.
dealing with the angle of depression and?
It's dealing with the angle of
elevation?
depression and the angle of elevation. So what it says, and we said that when we talked about it, it says, make sure you sketch the problem. All right, so what that means is, look at what it says. Sketch the problem, show and label a right triangle. So your sketch is going to be a what? A right triangle, right? and solve the problem and show me all the work. So if I say to you, the angle of all right, so let's look at the first problem, right? So you have a ladder that's X feet high, right? And you have a wall, right? Right? And it forms an 80-degree angle with the ground and the ladder. So like when you put a ladder down, right? You put a ladder down against the wall, what does it do? It falls toward the wall, right? The ground is your bottom. The building or the wall is your vertical leg, and the ladder is going to form the hypotenuse, right? Don't you think?
Yes.
All right, that's all it's saying. So like, for example, let me come over here for a second. If they're talking about a ladder falling up against a building, right? Here's a building, right? Does that make sense?
Do you mind moving the camera up just a bit? There you go.
There's a building, right?
Yes.
And the building stands on the ground, and I have a ladder. So the bottom of the ladder is here, and then it's a really big ladder. So here's the top of the ladder, and when I put it up against the wall, it hits the building here. And there's your triangle. So the building doesn't matter. See how that works?
So
And
that.
there's your angle of elevation.
Okay.
Does that make sense?
Yes.
All right. Now, if they were talking about an airplane, I don't know if there's an airplane problem in your picture. I think that might be an airplane problem, right? Yes? Yes, there is.
Okay. Yes.
So anytime you see an airplane, we're not going to be talking about an angle of elevation. We're going to be talking about an angle of
Depression.
depression, right? So your little airplane is up in the sky, right? Yes? You like my drawing?
Yes.
You can tell I didn't take art at Benedictine, right? All right, and here's the edge of the runway, right over here. All right? So your plane has to fly down to the edge of the runway. So the plane's gonna go from here to there. And there's a perpendicular to the ground, right? Yes? Does that make sense?
Yes.
So they're probably not gonna talk about the angle of elevation. They're probably gonna talk about the angle of depression. So the mistake people make is they think this is the angle of depression. That's not the angle of depression. You have to draw the horizontal. This is the angle of depression. Does that make sense? Which makes it congruent to this. Does that make sense? Buchanan,
Yes.
does that make sense?
Yes, sir.
So please, please, please don't screw up where the angle of depression is. Does that answer your question now?
Yes. I was just wondering
Yep.
whether 9 through 11 dealt with those angles, but I understand now.
Does that make sense?
Yes, sir.
All righty. Anybody else have any questions? You're using the Pythagorean theorem. You're using the law of sines. You're using trig ratios. Sometimes you can use different trig ratios depending on what you're wanting to do, right? Does that make sense? All right. Anybody have any other questions? Mr. Boboski told me that this class might be a little, there might not be a whole pile going on because you might just be working on your test, all right? My man Bruce has already finished the test. I hope they're right, Bruce. All righty. Anybody else? All right, well, you guys, why don't you just work on your test? I'll be sitting right here in front of you. And if you have a question, don't be afraid to ask it, right? Does that make sense?
Yes.
Are you guys cool with that? Bruce, my man, you can check out since you're already done. All righty? And make sure you have that in by Friday. Hey, Monday, we're going to start talking about circles, right? Right? Make sense? All right, so work on that test. If you have any questions, I'm standing right here.